Hello, welcome. This is Bob Dickinson, and today I'm here to talk about TeamSpark MCP Tool Vault, a new product we're releasing. So first, let's talk about MCP a little bit. I assume if you've clicked on this, you already know what MCP is, but it's basically the way that all agents and LLMs talk to tools and services. It started with coding agents, but it's increasingly going to be used by every kind of agent to talk to tools and services, and it's just going to be everywhere. It's just gone crazy in the last 6 months, and it seems pretty clear, for better or worse, that this is the way we're going to do this. So first, a gentle warning. I wrote a Medium article a few weeks ago that was maybe one of the most read Medium articles I've ever had, basically saying not to run MCP tools like this. If you look at a lot of the getting started guides, they tell you to run tools like this. They tell you to either type npm or UVX and then the name of the tool, and it's awesome. It runs magically. You don't have to install anything. You don't have to download anything. The tools just run. But the way they run is that npm for Node and UVX for Python essentially go to a registry, get the latest code in that registry, download it, and run it automatically. So you're just getting the latest code from some random repo, and you're running it as root on your local dev machine with full access to your environment and file system. It's probably the most dangerous thing I've ever seen anybody advise a developer to do, and developers do it all the time. It's kind of it's kind of crazy. You shouldn't do that, and I'll show you some help that we can give you in the future. But basically, it's very sketchy. So there are some general challenges with MCP servers. I'll first talk about some operational challenges. Right now, the agent support for MCP tool discovery and management is not great. In a lot of cases, with things like Cursor and Cloud Code, the user interface is essentially take this chunk of JSON and paste it into an MCP.json file in some magic directory, and the tool will just sort of show up. There's not really any feedback or way to see what tools are offered by the server or see if it even works. So a lot of times people use things like MCP Inspector just to sort of validate that the tool actually is configured properly and running on the local machine, and they just paste that into their environment. But it's kind of a mess. There's really no way to leverage common tool configurations across environments. So if you have a couple of Cursor projects and a Cloud Code and who knows what else in your machine, and they're all using some combination of tools, they're all maintaining their own configurations, they're all managing those tools themselves. There's really no way to centralize or manage that or have any visibility of it. Not all agents are compatible with all tools. There's definitely a lot of early adopter agents that have broken MCP protocol support. SSE in particular is broken on a lot of agents. We're starting to see more authentication and more advanced streamable HTTP MCP servers, and a lot of agents don't support those things yet. So there's definitely some mismatches where not every agent is going to be compatible with every tool, just potentially a problem. There's also really no telemetry tracing audit. There's no way to tell what tools are being run by who, when, what's going back and forth. It's just all a big mystery. It's just a bunch of code that just runs magically on your machine that you have no visibility of, which is not ideal. And then there are some security challenges, sort of separate and apart from the operational challenges. The first one being kind of what I referenced earlier, which is the tools are generally of unknown provenance. They're not signed. They're often run using insecure methods. They're often run with full access to your environment and file system and the internet. So obviously, some pretty big attack vectors there. That's one element of security. The other element of security is there's no visibility or security of the data flows between the LLMs and the tools. And you might think to yourself, well, do we really need that? I mean, we've been sending all kinds of data back and forth between these chatbots and the LLMs forever without any real security, and that hasn't really been a problem. And I'd argue the difference is in those environments, you usually have a human that's involved in the chat, or at least somebody that can look at logs from an agent, and you can see what's going back and forth between the chatbot and between the user and the chatbot, or between the agent and the LLM. And it's not surprising. It's typically like, this is the question that we asked, or this is the task that we gave it, and this is the response we got back, and it all sort of makes sense. So there is some transparency, even though there isn't a lot of tooling around it. With the LLMs talking to the tools, this MCP server security is the LLM itself talking to the tool and the tool talking back to the LLM. And you typically are not going to see the output of that. Some agents will give you the ability to sort of drill in and inspect that stuff, and some won't, but it won't be part of your normal course of operation, even if you have that ability to just sort of understand what's going back and forth. So you have this sort of secret conversation going on between the large language model and the tools, both of which I would argue are sort of suspect. And the two of them together having conversations that you're not in the middle of is also pretty dicey. And this is sort of my joke, but also not really a joke, which is this is how Skynet becomes self-aware. This is how bad things are going to happen. This is how companies are going to get taken down by their own AIs in the future, is by not having careful control over what's going on between the LLMs and the tools they use, and in both directions. And so today, it's sort of every agent for itself mode. This is what one desktop might look like, but you have an expansion of this if you look across an enterprise, where I've got a couple cursor projects and they have a couple tools installed each, and maybe they each have a file system tool, and they're configured differently for different file paths, and those might be run outside of the process of the cursor process, whereas these tools might be run inside. Then I've got Cloud Code, and it's got a little bit different set of tools, and it might be running SQLite outside of it. And all of these are configured separately and managed separately, with no real, shared access, no security, just sort of the Wild West. And our premise from the beginning has been that a better solution is an MCP gateway, which is what we've built. So you essentially have things like your cursor projects and your Cloud Code that have very simple shim configurations that point to an MCP gateway. And the MCP gateway manages all of your servers. This is also where we're going to handle security. This is where we're going to handle authentication. This is where we're going to handle secrets management. Sort of all the tricky parts about interacting with these servers we're going to handle at the gateway, so that the agents have a very, very simple, unchanging configuration that's going to be well supported. So let's talk about some of the benefits of this approach in the TeamSpark MCP Tool Vault product. First, operationally, you have a centralized place to discover, install, and manage your server. So you have one place that you can go install a server with a few clicks, nice wizards to help you install it. You have a liveness indicator, you can ping it, you can test the tools and interact with them and make sure they're working the way that you think they ought to work. As I said, because we're sort of doing all of the hard part of interacting with the servers at the gateway, any agent can talk to any server. The agents are just going to talk standard IO with a very simple shim and protocol, and the gateway is going to handle all the rest of it. So if you have a server that requires new authentication, or only runs with streamable HTTP or whatever, or requires some secrets, we're going to handle all that. And any agent that talks any version of MCP is going to be able to talk to those servers. We have full tracing, audit, and analytics. So you'll be able to see every message that goes back and forth between every LLM and every MCP server, and be able to kind of slice and dice that data if you want. And then in the sort of coming soon category, which I'm not going to demo today, we're going to be able to detect the agents, auto-convert the tools those agents use, and centrally manage the tool configuration. So we'll sort of get the agents totally out of the business of managing what tools, how the tools are configured, and do that all centrally. And then I think later there's an obvious opportunity for enterprise delegation, for more telemetry, things like cost management, auditing tool access, things that are going to be more applicable to an enterprise deployment of this kind of product. And on the security side, there's two aspects we look at. One is the actual server, MCP server security itself. The lowest hanging fruit, we think, is just running servers in containers. And we've come up with a solution to do essentially a one-click containerization of a server. So if you have an NPX or UVX server like the one I pointed out earlier, we have a solution where you can secure that in one click and run it in a container. I think that gets you most of the benefits of some of the more sophisticated solutions, not all of them, but it's super easy and simple, and you can do it today. We have automatic client authorization and gateway server security. And I point that out here because there are solutions in this space doing things that are similar to this. And I will say that if your solution to managing or centralizing or securing MCP servers involves exposing those servers via HTTP on your local machine, and you don't secure that endpoint, then you're just trading one set of security vulnerabilities for another. Because now you have a server that's running that potentially has access to secrets and access to environment and local machines and remote services, and that thing is now available to anything running on your local machine. In some cases, you might have actually made it worse because you might have had a standard IO MCP server that you were execing within an agent, where at least that configuration and that access was constrained to that agent, and now you've exposed that to the whole machine. So it's super important that if you are going to expose servers on a local machine or on any machine, in a solution like this, that you secure those endpoints, which we do. I think later, and maybe this is not much later, I think there's a lot of benefit and a lot of advantages to things like having a trusted server directory, being able to understand the provenance of MCP servers, having them digitally signed, being able to enforce operational profiles to say, like, this is what the server can do, this is what it can, who it can connect to, and what kinds of activities it can do, and be able to enforce those and know they're enforced. I think advanced authorization authentication support is coming soon. As that evolves, it's going to be important. And there's a lot of people working on this. The StackLock team with ToolHive is doing a bunch of this stuff and doing a great job of it. And we may integrate with some of those things later. The other side of this, which I think is equally, if not more important, is the MCP server usage security. So that's the security of the actual data flow. So that's looking at what's going back and forth between these LLMs and the tools, and being able to apply some policies to those. So being able to do things like detect PII, detect API keys and secrets, all kinds of other things. And I'll give you a bunch of examples of some built-in policy filtering, but you want to be able to see what's going on. You want to be able to flag things that look suspicious, and you want to be able to, in some cases, redact or go into an error state if something is happening that you don't want to have happen. And I think down the road, there's room for other things like risk assessment and rate limiting, things that you would do like on a larger basis, on an enterprise basis, for server usage security. So the foundation of this is MCP Link, which is an open source project that we released about a month ago. And it essentially allows you to bridge any MCP server to any interface type. So let's say you had a streamable server and you wanted to serve that up via standard I/O to an agent that could only talk standard I/O. You can do that with this thing. It also allows you to expose multiple MCP servers of any type at a single HTTP endpoint. So you could stand up an SSE or a streamable endpoint, and have a bunch of different paths that endpoint point to a bunch of different servers that could all be using any protocol type. It has a message processor hook, so when you use MCP Link, you can sort of install yourself in the middle to watch all the traffic going back and forth and interact with it if you want to. And it also supports authorization. So a decent chunk of what we built was based on this little core widget that we started to deploy in a couple different use cases. And let me show you how we use that in the actual product. So the TeamSpark MCP Tool Vault is itself a server that exposes a web app and an API, runs on your local machine for now, doesn't have to run on your local machine. And it exposes an MCP gateway, same process, but a different port that actually allows clients to talk to a variety of managed MCP servers. And the way it actually works is that the client, so this could be something like Cursor or anything that talks to MCP, is going to run a standard I/O shim based on MCP Link. So this is a little shim, a couple hundred lines of code that's wrapped around the MCP Link open source library. And it exposes itself as an executable called TSH for Tool Vault shim. So your Cursor client is just going to run TSH and then the name of the server it wants access to. So what actually happens when your agent fires up this shim and starts a conversation, this will connect, it'll auto-discover and connect to the Tool Vault server, and it will say, hey, I want to get access to this server. If there's a client authorization token, it'll pass that as well. Either way, it'll get back a link that has a server configuration and bearer authentication to that server. So it'll basically get back a configuration over here, and it will use that configuration along with the bearer token to connect to the gateway. And it'll be able to make an authenticated connection, an authorized connection to this gateway to talk to the server. And when it does that, when then it starts passing messages back and forth, it thinks it's just talking to the standard I/O shim. It's actually going through the gateway. The gateway is passing those messages through a message processor, which is doing message tracing, storing copies of the message, applying policy filtering to the messages, and then sending them onto the server. And then the same thing happens in reverse. Server responds, goes back through the message processor, and then back to the client. So pretty straightforward. It's kind of a forward proxy, reverse proxy combination, where we're sitting in the middle as this gateway, applying policies to all the messages, and trying to do it in as secure a way as possible. So let's jump into the demo. This is the demo of TeamSpark MCP Tool Vault. I'm going to start out at a very high level and just kind of tool through the menu items just to give you an idea of what the core concepts are, and then we'll come back in a little more detail and show you how each of them work. So first of all, we have a dashboard. The general idea here is just sort of to give you a quick overview of what's going on in the system. We have a list of servers, so these are all your MCP servers that you have installed. We have a list of your clients. So when you first start, you don't have to set up any clients. You can just do this without client tokens and just start running this and accessing these servers. But if you want to be able to authenticate individual clients and you want the communication, the authorization to be secure, then we can set up individual clients. And then you'll also be able to track the policy application and the messages by client. We have a set of policies. So policies are essentially sets of kind of rules that have filters attached to them that are looking for various kinds of information and then taking various actions on those pieces of information. We have messages. So this is going to be all the messages that are flowing back and forth between the LLMs or agents and the tools. We have alerts. So this is anytime a policy criteria is met, it will create an alert for that policy that will tell you what happened. We have a set of settings, pretty basic, just your host settings and some simple application settings. We have an API documentation test server, and then sort of a help and support section. So let's go back to the dashboard. So here we have, at the top, we have the new policy alert. So if there there aren't any new policy alerts, this section won't be here. But if there are, you'll see the alert by severity. We see our gateway host. So we see our gateway host is running SSE on port 4000. It's currently running. We can start and stop it. We can see how many servers we have. We have 4 active, 1 disabled, 4 clients, 9 policies. We can see that we have active message flows. The basic point of this is just so you can see that, yes, there are messages flowing, and we have alerts. So you can also see, yes, there are things getting alerted. So it just gives you just a very high level detail. And the idea from here is that you'll then go drill into whatever individual thing that you wanted to get more information about. So let's first look at the servers. So we can see the list of servers, the server info that we got when we queried the server, when we pinged it. We have a security column. So the security options are essentially container, which means that it's containerized. We have network, which means it's running over the network. We have run in container, which means that you've told us that you want us to run your UVX or NPX server in a container, and we've done that for you. And then we have unknown, which is sort of the scary one. So in a perfect world, you want these all to be blue and everything to be either running in a container or over a network where you're comfortable with the security of what's on the other side of the network. Let's go look at one of these in some more detail. So we can see we have this everything server. It's enabled. It's a standard IO server running NPX, and then we can see all the details. So this is what we got from the server itself. Last seen shows us the last time we've seen a message. So this shows you some sort of recency activity of that server. Standard IO, NPX, here's some args, environment variables, and security. And if we wanted to, for example, let's say this is unknown security, it's NPX. So we can go in here, hit run in container, save, and now this is running in a container. So like I said, super simple, 90% of the benefit of what you're going to get out of much more advanced security solutions is just running these things in a container by clicking one button. I can go in and look at tools. So I'm looking at the everything. So I can see I've got, pretty sophisticated tool testing operation environment here. Let's see if I want to echo something. Let's say hello. And I got it back, response back. So I can actually go in and test all my tools, see how they're working, how the service is configured. I also have all the messages and all the alerts that are related to this particular server, just as a kind of a quick way to pivot into those things. You can also see them obviously you can filter them at a higher level. And I can ping the server. So just to verify that it's working. So pretty basic. I can view it as JSON if I want. I can view the server configuration as JSON since it's a kind of a common way of interacting. And actually, when you're editing, you can also edit as JSON if you'd rather do that. So you can cut and paste the JSON in there instead of editing it, with the fields. So let's go look at clients now. So for each client, we have sort of the type, description, same kind of a thing. We can see the messages and alerts from that client. We have a token. That's a value that will be used to configure that client, identify it and authorize it. We have the configuration path so that we can update the tool configuration, whether it's auto update, last time it's updated, ability to update it right now, and then the set of tools or servers that client's going to have access to. So let's actually do this. We'll do a little test of, we have TeamSpark AI Workbench. I could do this with any LLM agent tool. I happen to have good testing tools in TeamSpark AI Workbench, so we'll just do that. But this would work fine in Cursor or any other tool. So let's go get this token. And let's go into, this is TeamSpark AI Workbench, and we're going to add a server. So we're going to go in here, and so let's add everything. It's going to be a standard IO, TSH, which is our shim. It's going to take 2 parameters, the server that it wants access to, and that token. So let's save that. And now you can see that we have this server. So the server's installed and I can see all the tools. So it means it actually connected through the gateway to the server that's running in the tool vault. I can ping it, 13 milliseconds. Let me go test something. So let's try something else. Let's test echo, but let's give it some more fun data. So let's give it a fake Amex number. So what you see when I tested it is it sent the message Amex, and instead of getting back Amex with that number, it got back Amex redacted. So it actually went through and applied a policy to redact the Amex number. And this is happening through a third-party agent. I mean, it happens to be my own tool, but like I said, this is exactly what you would do to configure and use any other agent. Super simple configuration. So let's go back here. And one thing I can do is, let's go back here. if I go to alerts, I should be able to see this alert right here, this message that just came in. And if I click on it, I can see there's my American Express. And this is sort of interesting because you might say, well, okay, so the echo send it to and from the server. So how do I know if I got redacted on the way to the server or on the way back? So here we can actually see that. We can see that we have an American Express filter. That's what it matched. It redacted it in the params sent by the client to the server. The server got that and responded with the same redacted text. So we can sort of see not only that it got applied, but like where in the process it got applied. Okay, let's go to policies. So I'll just pop into a few of these just as an example. So we have cloud account secrets, which is looking for AWS access keys, secret keys, Google API, cloud keys, generalized secrets, so JWT tokens, private keys, prefix secrets, bearer tokens, GitHub secrets, LLM API keys, so Anthropic, OpenAPI, Hugging Face, etc. So just to give you an idea of the kinds of things we have. And I'll go through just a little bit of an example. Let's look at credit card numbers. So the way these policies work is they have a name, a description, they have a severity level, they have an origin, which means that you can look at only messages that originate at the agent or only messages that originate at the server if you want. Generally, you're going to look at both directions. You can also limit them to only certain methods. So this one only applies to tool calls, but you can have it apply to everything or specific methods. The action it's going to take, in this case, it's going to redact with this phrase redacted in all caps and bracket and square brackets. And then you have a set of filters. So what a filter is, it's got a name and a description. It has a regular expression. The regular expression is sort of the driver of this. The regular expression has to match in order for anything else to matter. But if the regular expression does match, then a couple of other things can happen. If there's a validator specified, that's a function in our code. The validator will also be called. So in the case of credit cards, we have a bunch of patterns that deal with like the length and the opening digit combinations and a bunch of other things that are reasonably decent. But you're going to catch a lot of stray 13 to 16 digit numbers if you do this. But there's a validation called Lewin validation, which is a checksum based validation that all credit card numbers use. So we can apply that on top of this, and that cuts the false positives to almost zero. It's pretty effective. So in this case, we're going to say, hey, you want to know if you're matching these credit cards, we're going to match the regex. If the reject matches, we're going to call the validator. If that matches, then it's probably a credit card, and we're going to flag it. And we're going to flag which filter actually applied. So we're going to say, hey, it was a Visa or it was a MasterCard or whatever. We'll go into one other example of PII. And that is that we have some things like social security numbers that are pretty hard to identify just based on the content, because it could just be any 9-digit number. It could have separators or not separators. So we have another concept in our filters called keyword. So a keyword is basically is going to be a whole word match that has to occur within a context window around the regex match. So if we find something that looks like a social security number, we're going to look around that. It happens to be about 100 characters. We're going to look about 100 characters before or after that match to see if any of these phrases occur, any of these keywords occur. And if they do, we're going to consider that to be a match. And you can use those in combination. So you can basically have validators and keywords. But the regex has to match first, and then the validator the keyword is going to be further qualification on that. So let's go look at messages. So messages is essentially where we can see all the messages that have gone through this gateway in however long you have message retention set up for. So we can switch the time period for the charting. So let's go to 30 days. We can also filter, well, actually before that. So we can see the basic, we have the server, the method, the tool, if there is one. None of these are tool calls. The client, whether there was an alert on that message, and then the timestamp. But I can also filter all these things. So I can filter on what server, on what method, what tools, clients, source IPs, or session ID if I want to really drill into it. So let's just filter on tool calls, because that'll make it a little bit cleaner. So tool calls, you can see the graphs updated, and now all of these are actually tool calls. So let's just click into a tool call message. So this is one that doesn't have any policies applied, just a basic message. So what we can see is the client was Tool Vault, the server was everything. This little arrow indicates that it was a message sent from the client to the server, and the server responded. There are notification messages where they only go one direction or the other direction. So that arrow sort of tells you whether to expect to see params and results. And we can see the method, the basic information about it, the time, and then we can also see the payload. So we can see the params that were sent by the client and delivered to the server, and the results sent by the server delivered to the client. So very just sort of basic message inspection. And like, as I said, so you're going to have like things like notification messages. So a notification message like that is going from the server to the client. And then you'll have notification messages during protocol negotiation that go from client to the server. So it's sort of easy to understand the flow of all that. All right, let's go into alerts where it gets sort of fun. Again, we can sort of toggle the time frame, and we'll have these new policy alerts. This only shows up if there are already new policy alerts. Then I've got my alerts by date and policy type, and then by severity. And similarly, I can filter on policy, on filter, on severity, status, server, and client. So I can sort of drill in any way that I want. So let's say if I just wanted to filter on, so just like I want to look at the criticals, so I can see there's a bunch of criticals, what servers they came through, and there they all are. Let's clear those. And then let's go look at this. This is a good sample one. So let's start out with this. So we see in the message, so this is from cursor to everything, and I triggered 3 alerts on this one message. This is a little bit of an extreme example, but so I've got the param sent by the client, and I have something that looks like a phone number, which I redacted, and I have something that looks like a social security number, which I also redacted. And then if we look at the response, I have this Visa one, and I can see I have a Visa number there, and I redacted the Visa number. So in each one of these, I can see that, okay, this is a severity 2. It was credit card numbers. It matched the Visa. The action was to redact, and there was one match in this payload somewhere. Now let's try another kind of. Well, this is not a. Nope, that's not what I wanted. So I can load more. All right, I have a specific one I want to find, so let me just go look for it. All right, so this one I have 2 things. I have a UUID pattern, which is that one, and I have a private IP address. So private IP address is low, and the UUID is info, which means it's maybe not even alert at all, just something you want to sort of keep track of. And when you go look at what happens in the output, you can see that on the internal network details, I redacted that, and that looks specifically for things that meet the RFC definition of internal network addresses. But for the UUID pattern, I didn't redact it. So you can see, okay, this is what I identified, and it made its way through in the payload because I didn't think it was necessarily a big deal. So let's go through. We have OpenAPI documentation for the API server that you can actually run and test here. So let's say I wanted to let's just test something really simple, like list the servers. I can go try that out, and I can get a list of servers. So pretty straightforward, but basically everything that you've seen demonstrated in the UX is done through the API. So the API does everything you've seen, and the API actually does a significant amount of things that aren't in the UX. There's a lot more analytics and dimensionality and other support in the API that isn't exposed in the UX. So you can pretty much do anything, populate any of this data, interact with it, do analytics on it, all through the API if you want to. Pretty straightforward. And again, help is just sort of help, pretty basic help. I imagine most of that help will be on the internet, but we'll build a little bit into it. So anyway, hopefully that is interesting to you and gives you the idea of what we're going to be able to do, the ability to easily set up these servers, manage them in one place, see all the messages going back and forth, set up policy alerts, and secure the communication between your agents and your MCP servers. So hopefully that's interesting. If it is, give me a like and follow or reach out, and we'll get you on the beta list and you can start playing with it. Thanks a lot.